All right, first thing is just kind of defining what chapter 18 is all about. It's really just electrochemistry is what it's called. It's really studying the conversions from chemical energy to electrical energy. If I were to kind of simplify it as simple as you could get, would be just the processes and the things that convert electrical energy to, or sorry, chemical energy to electrical energy, or the other way around. Okay? So a lot of battery-related stuff, a lot of chemistry and solutions where charges are moving, specifically usually ions are moving. We will spend some time talking about how batteries work and a few other things in this chapter. The goal for the rest of the year is to get through 18.5 and one section in the nuclear chapter and then give you your final on that. So your 2 sections in chapter 4, there will be 5 sections in chapter 18 and then one section in the nuclear chemistry chapter. That's the goal. And then your final will be on Tuesday and Wednesday of senior finals. Got it?
So, the week after next.
Yes.
I think most of the finals that week. Tuesday.
Yeah, since it's not like a full hour and a half like you normally get for a final. I mean, I'll probably just give you one section of it one day, and then another section of it another day. Unless, you know, you get through the first section in 20 minutes, then I could probably give you both. But usually it takes you longer. So we'll just split it up into 2 different days.
So can you like study for the first section?
Depends how I do it. Probably not 100 books. Be probably the idea. Do like one test, just unless you want me to just have you do all the tests on one day. I don't care. You guys can decide what you want. But if I do split up into 2 days, probably not to be able to like go back and study. Because you wouldn't get that on a final. We'd have to do a whole hour and a half. But since class period is only 40 minutes, I want to make sure you have a full hour and a half. Alright, so before we get into the second method of balancing, we need to talk about what a half reaction is. It's really not overly difficult. It's just taking a situation, so I'll write this up here. C plus okay, all a half reaction is really what we've been doing. We've been identifying which one gets oxidized and which one gets reduced. Okay, so this guy gets what? Okay, so it goes from 4 plus to 3 plus, that got reduced. And this one goes from 2 plus to 4 plus, it gets oxidized. And we can say that the guy that got reduced is the oxidizing agent, yada, yada, yada. So what is a half reaction? It's just taking the reduction out and taking the oxidation out. So I would say that the reduced or the reduction half reaction would be this. There's one of your half reactions. The other half reaction is that guy. So basically, when I ask you to do a half reaction, what you're just doing is you're taking the part that gets oxidized and writing just the equation for that, and the part that gets reduced, writing the equation for that. Okay, they don't understand why I put the 1 electron and the 2 electrons where I put it. Okay? This guy gains an electron, so I put it there. This guy lost 2 electrons, so that's why I put it as a product. Okay, so we are going to do balancing redox reactions with when it's in a acidic solution or a basic solution. And I've given you kind of a little bit of a step-by-step process of how to do this. It's a little bit of work. Okay? So, we're going to start out with this one. So have that sheet, a little step-by-step process. I should have given myself one so I had it in front of me. I don't have it fully memorized. I have a good enough idea that I can figure out what I have over here. That's good. So, what is your first step? Oh, I should probably identify this as an acidic solution. Okay, of that sheet I gave you, the top portion is dealing with acidic solutions. What does it say we should do first? Okay, so we are going to write the 2 half reactions. In order to do that, we probably should write the oxidation numbers up here to figure out which one gets reduced and which one gets oxidized. Okay, what's this? Here?
7 plus.
Uh-huh. This one?
2 plus.
And, okay, with that information, we should be able to write each half reaction. Step 1. Okay? Looks like this would be one, and this would be the other. Do I see it?
Yeah.
So my first half reaction will be this.
What happened to the oxygen? Just what solution?
We'll deal with that later.
Do you write the like plus?
Yeah, I should probably write +4 or +7. Goes to +2, and I can say that this got reduced.
So you don't need to write like +5 electrons on the left side.
Not yet. We'll deal with that once we go a little bit further. I mean, you could now, but the other one we got Fe 2 plus goes to Fe 3 plus. Let's say 2 plus to 3 plus. Oxidized. Now, do you need to write which one got oxidized, which one got reduced? No, that's not necessarily the most important thing to do. I'm just writing it up there to make sure that we're thinking about that. Okay? Then in number 2, it says to do a bunch of stuff. Okay? What does it say to do in A of number 2? Okay? Now, if you look at this situation, all the elements except hydrogen and oxygen are already balanced. So I'm just going to write Mn is balanced. Don't have to do anything.
Make the charge.
No, just the atoms. Okay? Now I'm going to do I'm going to do 2 for this one first, and then I'm going to go do step 2 for the second half reaction next, so that we're not jumping back and forth. Okay? In B then it says to balance the oxygens, correct, with water, right? Is that what it says? Okay? And the reason why we can do this is, it's in what?
Water.
It's in water. Okay? So we can do this. So we'll go Mn, O4 minus, goes to produce Mn2 plus how many waters would I need to balance the 4 oxygens on the left? Okay? So I've used the fact that we're in water to be able to balance those oxygens. I believe the next step, I don't have it in front of me, but I believe the next step is to balance the hydrogens with just your hydrogen ions. Now, why do you think we could do that? It's in an acidic solution, and what is pretty prevalent in an acidic solution? H+, okay? So, 8H+, everyone see why it's 8? Got it? Got 8 hydrogens over here, so I've got to have 8 over here.
Why wouldn't it be H2?
Because that would be H2 gas, which isn't going to be in solution. It's got to come from something that's already there, and in an acidic solution, we have a lot of this. It's already there. Okay. Now my charges need to be balanced on both sides, so this is where I suggest putting in how many electrons you need. And I think that's what step D says. Can someone read step D? Just charge. Okay? So we have 8 positive, 1 minus, 2 positive, separated here. So I need to get this side to match this side for a charge. How many electrons and where would I put in to get the charges to balance out?
6.
Well, what's the sum of these two? 7 plus turns into 2 plus. So 5 electrons, which side would it go on? Left. Now I should have 5 minus, 8 plus gives me 3 plus, 1 more minus gives me 2 plus. My charges now are balanced on both sides. Okay? I finished step 2 for this half reaction. Now I'm going to go do step 2 for this half reaction, and you'll find that it actually is a little bit easier because there is no what? Oxygen or hydrogen. Okay? So if you look, step 2A would be balance the non-oxygen hydrogens. That's already done, right? B would be balance the oxygens with water. We don't have any oxygens. C would be then balance the hydrogens, but we don't have any hydrogens. So really, we just have to do step D, which is what? Balance the charges. Okay, so I've got to add 1 electron. Where am I adding it? So what we found here then is in this half reaction, the reduction process, we had 5 electrons, okay, that it gained. And over here, we had a half reaction that got oxidized and lost how many? 1. So we have 5 gained, 1 lost. Okay? This is where step 3 comes in, and I'm running out of space.
Why do you have an H plus? Or an 8 plus?
8. Oh, that's because I have 8 of the 1 positives.
So why would you have 4
For
on
what?
H2?
Because this is not a charged compound. I'm just talking about the overall charges in these guys. This has no charge, it's neutral. This has a 2 plus charge, this has a 1 minus charge, this has a 1 plus charge. I have 8 of them, I have 1 of them, I have 1 of them. Okay, so that we're not looking at the individual oxidation numbers here, we're looking at overall charge.
Then why did we have to gain 5?
Well, then it matches up, right?
So what was the point of gaining that
To
charge?
balance the hydrogens and oxygens. Okay, we had to balance the hydrogens and oxygens with the things that are in an acidic solution, water and H+. Now along those lines are some charged particles. Some electrons are gained or lost. Okay? So if we look over here then, 1 versus 5, we've got to do step 3, which it says, I don't remember off the top of my head, it has to do with balancing the electrons. Okay, so we're going to multiply a half, one or both of the half reactions so that the electrons balance. Okay? In this situation, we only have to multiply 1 because I can take and multiply this reaction by 5 to get 5. But if this was like a 3 and this was a 2, do you see how you would have to multiply both? You would have to do the least common multiple in a situation like that. So that's why it says multiply 1 or both depending upon the situation. So, I'm actually going to write step 3 over here since I'm going to be dealing with that one. Okay, so I'm going to take this and multiply the whole thing by 5 to get this to work out. Now step 4 says take the two half reactions and add them together again. So now that we have balanced my electrons, put them back together, and start simplifying. Step 4 here. Got 5 electrons. Now we gotta take the reactants of the other half reaction. And my products of my two guys. Now I've taken my two half reactions and I have combined them together. Make sure to see if there's anything that can reduce or cancel out. Well, obviously, what are the things that should and will reduce and cancel out? Those electrons. Really, technically, the last step is you're checking. You're trying to figure out, okay, do all my charges work out and make sense now? Do I have all of my elements balanced? Well, I've got 8 hydrogens on both sides. I got 1 manganese on both sides. I have 4 oxygens on both sides. And I have 5 irons on both sides. So my atoms are balanced. Let's make sure our charges are balanced. I have 8 positive things there. I have 1 negative thing there. And I have 5 2 pluses. This way. Everybody see what I've done there? I'm adding up all the charge. I think this gives me 17 plus charge. Now my hope is that the other side will also have a 17 plus charge. Because if I came in with a 17 plus charge, I must go out with a 17 plus charge. Otherwise, I have gained or lost electrons. Can they transfer from one element to another? Yes. But if I have a 17 plus charge going in, I better have a 17 plus charge going out. Let's make sure. We got 2 plus. Okay, that's neutral, ignore it. Plus 5 times 3 plus should give me my 17 plus. So then your answer to the balanced chemical equation, if all the atoms are balanced and all the charges are balanced, is this. Questions? Any? Obviously, this is a little bit different than what you're used to, because what they just gave us was the stuff that got oxidized and reduced. They didn't give us any of the oxygens or the hydrogens, but the fact that it is in an acidic solution, we have those with it. Okay? So, in order for this to happen, to balance, to get all the electrons and protons to balance out, this is what has to happen. All right? Let's do another one. I think we got another one, right? We have another acidic solution here. Same step, same process. First, we should probably figure out the oxidation numbers to know what gets oxidized and what gets reduced. What does chromium have to be? So 1 plus, 1 plus, 2 minus. Looks like we got 6 positives. And so therefore 4 positives. What does the carbon have to be? Okay. Wait, did I put a
Wait,
plus?
minus.
Yeah, sorry. Put minus there, like that. This is an ion, so we know it's 3 plus, 2 minus, 4 plus, 2 minus, 1 plus. We gotta figure out what is my 2 half reactions gonna be between. What do you got? Maybe 1 1/2 reactions. Let's say what one. Okay? CrO7 minus going to produce. Oops, sorry, CR2. There's my first half reaction. What's my second half reaction? Okay, carbon. This isn't super necessary, but again, we can do it. 6 plus, the 3 plus, got reduced. It's 4 plus, right? Minus the 4 plus, that oxidized. Okay? Step 2. Don't have to do anything for A. Yep. Gotta balance my chromiums. keep forgetting to put the 2 there. Okay, how many? And where?
It's on the right side.
Yep. And I balance my oxygens with water. I do it again.
You got the L.
What?
You got the R2. R2, not C.
Oh my goodness.
Chromium, not carbon.
I'm struggling with this chromium. What did you say?
Anytime you like mess up, just have to do the last round.
Really?
Yeah.
Oh, I saw the one.
So,
One of me said the gift of the guy studying type.
Yeah, and then what you did the other day.
Yeah, that's true. Yeah. I did not make. It was sent to me.
Who sent it to you?
Riley.
Riley?
yeah.
Why?
It's funny.
Yeah, but what? Riley Ward?
Yeah.
Why was she thinking about physics?
I don't know. Put it in a group chat.
Yes. I'm glad I got students not in my class thinking about my class. That's a goal. That's a good goal.
I mean, I don't know. I was talking about it. You don't need to study all.
Yeah, we do. Gotta balance the hydrogens, right?
Oh.
14 of them.
Wow.
14 bad boys. Yeah.
New.
They are not a.
Hey,
New 14 bad boys. They are not a. No, it's on camera now.
sorry for that.
It's different.
Right. Then D is where we gotta make sure we get our electrons balanced. So we have 14 positives. Okay, and 1, 2 minus. And then over here, we have 6 plus. So, I got 12 plus to 6 plus.
I wonder. What's full?
12 plus to 6 plus. Where are the electrons going? How many? How many of them on the right side? Now you could probably not rewrite everything over and over and over like I am. But at least early on when we're not quite super good at this yet, it wouldn't be a bad idea, and that's why I'm doing it. We gotta do the same thing now too. The other one. Okay, you gotta balance everything that is not hydrogen and oxygen, which is just the carbons. Oops. Then balance my oxygens. This was fun. Not really. What do I gotta do? How many and where? How many on the left? Three. I have 1 here and 4 here. So I need 3 more oxygens on this side. What'd you say? It's a little bit more follow a procedure, unfortunately. Well, sometimes we can, even when I do some of this stuff, I lose track of what's really happening and what the why is behind some of the stuff. Okay? Which is easier from a math standpoint, but you start to lose some of the conceptual stuff. Okay, now I gotta balance the hydrogens. Holy heifer.
Yeah, 12.
12 to their left.
That's all the way.
What's the number?
Yeah.
How many? 12? Woof that.
There's 14 on the left.
I know. Yeah, but look at, those are the only charged things up there. So, which means in D, I need, where do I put them?
On the left. Right.
Done. So I've got my two half reactions all worked out, so they're balanced. Electrons are figured out. Now I got to make sure that the two half reaction electrons will be equal. That's what step 3 is asking. So do I multiply both of them by a coefficient or one of them, and if so, which one?
The left one by 2.
Okay. Woo! What am I doing? Didn't do it to all of them.
Wait, I didn't step 4.
Step 4 is taking the two and putting them together. Step 3 is making sure the electrons will match up so that when you do add them all together, the electrons will cancel out. And when I do step 4 here, I'm just going to eliminate the electrons. Is that cool? I'm not going to rewrite 12 on both sides. We know they're going to cancel out. Okay. Also, what I'm going to do is there's some other things that are going to cancel out. I got 28 hydrogens here and I have 12 on the other side. So those will cancel out, giving me how many? Is there anything else up here that we have to worry about canceling out? H2Os. Okay, so I'm not going to write any more H2Os on the reactant side because those 3 are going to get canceled out. Following? So I need to subtract the 3 from this. Everybody understand why I'm not writing 14 H2O? I feel like I did something wrong. Nope, I didn't. Okay, let's check to make sure everything works out. A little bit more work to figure out the hydrogens work out. We got 16 and 6 is 22 and 22. We have 4 and 4. We've got 8. No. Yeah. 14. 15. We've got 11 and 4 is 15. Okay, so it looks like all the atoms work out. Chromiums are 4 and 4. Well, let's just see if the charges work out. We got 16 positives on one side here, along with 4 negatives. Gives me 12 positive, and that should equal the other side, which is 4 times 3 plus is 12 positive. Now, what you do for a basic solution, you can see what you can read what it says. When you're using a basic solution, you basically do most of it like an acidic solution, and then at the end, you neutralize all of the H plus with OH minus. So let me explain what I mean. let's say this is a basic solution. We would do everything the same way until we got to here. Okay? I would say, oh, it's a basic solution, so I probably don't have a bunch of hydrogen just sitting here, right? So I'm going to take an equal amount of OH and put them on both sides. I would put 16 OH here, which is going to take these guys and turn them into what? Water. Right? 16 OHs with 16 H's are going to give me just 16 water. And then on the other side, I'm going to put the same amount of OHs. So I would have 16 OH minuses on the right. After you do that, do your final steps. Make sure your waters cancel out if there are on both sides and whatnot. Otherwise, it's done exactly the same way. Just at the very end, we know we cannot have a whole bunch of hydrogen sitting in this reaction because it's a basic solution. So we just neutralize the hydrogens
Add 16 OH to the other
to
side.
both sides.
Both sides?
Well, I gotta do it here because I actually have to neutralize them to keep the charge balanced. So what you're essentially doing is removing the charge here and putting it over there, the opposite over there, okay? But we've also got to maintain things balanced, and so that's why we do the 16 on both sides. So it'll keep all the atoms balanced, which essentially then just converts the positive charge here to negative charge on the other side. Is really all that it does. Okay? I don't even know if you'll have a basic one in your homework, but is there really only one problem? I mean, I realize it's a long problem, but
It's